Hi friends, here is a wonderful problem. We are given a quadratic equation x square plus bx plus c equals 0, where c is negative and b is positive. B is positive and c is negative. And alpha beta are roots of this equation. Alpha is less than beta. Right. Then what can we say about these roots? Basically, it is about when this equation, when given a quadratic equation, wherein the coefficient of x is negative and constant is positive. Sorry, coefficient of x is positive and constant is negative. And alpha beta are the roots. What can we say about the nature of these roots? Right. It's a nice problem. Let us see. Ax square plus bx plus c. This is in this format. Okay. So now firstly, the coefficient of x square is positive. So that means the graph is facing upwards. Right. The graph is facing upwards. How we can say this? Because when x is very large, these two terms will become small when compared with this term. So ultimately, the x square term will dominate. So for example, when x is 100,000, 10,000, 1,000,000, 10,000,000, whatever, bx plus c will obviously be lesser than x square. Right. So when x becomes large, the function has to become positive. That's why it is facing upwards. Okay, we don't know whether this is here in Q1, Q2, Q3, Q4, whatever, we don't know. Okay, where is the vertex? We don't know. Right. Okay, this is the first point. It is facing upwards. At the same time, alpha, beta are the two roots. That means clearly it is touching x-axis. It can be like this. It can be like this. It can be like this. Anyway, okay, it is definitely touching x-axis. That much we know so far. So firstly, coefficient of x square, that is a, let's say, equals 1, which is greater than 0. So that means graph is facing upwards. It is facing upwards. At the same time, two roots. There are two roots. What does that mean? Touching x-axis. X-axis. It is definitely not above x-axis, not something like this or something like this. It is definitely touching x-axis. But whether it is touching like this or like this or like this, that we have to still see. Now, b is greater than 0 and c is less than 0. Okay, so where is the vertex? We know this is the vertex of ax square plus bx plus c, that is minus b by 2a. Here a is 1, so it is minus b by 2. Minus b by 2. Right. And b is a positive number. B is greater than 0. That means minus b by 2 is a negative number. This is negative. Okay. So that means vertex is towards is somewhere here in Q3. Vertex in Q3 because minus b by 2 is negative. Okay. Please see it again. What is the vertex? Vertex of a parabola. Ax square plus bx plus c. We know it is minus b by 2a. Okay. Now a is anyway 1, so this we can ignore. Minus b by 2 is negative because b is positive. Minus b is negative. Minus b by 2 is negative. Okay. So the x coordinate. What is vertex? Vertex will have two coordinates. One is x coordinate and y coordinate. Y coordinate is anyway negative because this graph is touching x-axis. So it should be y coordinate is anyway negative. Okay. So now x coordinate is also negative. Why? Because minus b by 2 is negative. So the graph is not like this because in this case x coordinate is positive. X coordinates of this vertex is positive. Okay, it cannot be like this also because x coordinate is positive. It has to be, the vertex has to be in Q3. Okay, it can be something like this. It can be something like this. It can be something like this. Okay, where the vertex is here or vertex is here. So vertex is in Q3. That is fine. Now, this C, what is C? C, what is C? This C is less than 0. What is C? We know there are two ways. C is product of the roots. C by A is product of the roots. alpha beta are the roots, and alpha beta product of the roots is less than 0. What does that mean? One of the roots is negative, another root is positive. Otherwise, the product will not be negative, right? If both are negative, then product will be positive. If both are positive, then also product will be positive. One root should be negative, another should be positive. Then only the product should be negative. What does that mean? We derived that vertex is somewhere here, and one root is negative, another root is positive. So the graph will look something like this. Okay, the graph will look something like this. Okay, another way of looking at this C. What is C? C is the point when x is equal to 0, because this will be 0. When x equal to 0, whatever is, when x equal to 0, whatever is the y coordinate, that is C, right? So that means 0 plus 0 plus C. When x equals 0, whatever is the y coordinate, that is C. In ax squared plus bx plus c, we substitute x, ax squared plus bx plus c. If this is the equation y equals to this, then when x equal to 0, y equals c. So c is the y coordinate when x equal to 0. Oh, this is c. Okay, c is negative, that is what that is given. Now vertex is already negative, right? So graphically, if you want to see, there is a vertex, there is a point, and there is a c. Okay, and if you are connecting this by a parabola or even a straight line, okay, this line will touch this x-axis at a positive value only. So this root will definitely be positive. If this c, this instead of c is negative, c is positive. Okay. So for example, if c is positive, then whatever parabola that you draw, okay, whatever parabola that you draw, or in fact whatever straight line that you draw, even if you draw a straight line, this will touch negative x-axis. That means the root will be negative. Here, if c is negative, that means root will be positive, because one root will touch, it will anyway be here. The second root will touch at a positive, on the positive x-axis only, right? When c is negative, that is the significance of alpha, beta, or c is less than 0. Product of the roots is less than 0. That means c is less than 0. That means if one root is already here, this is the vertex. If we are trying to draw a parabola or trying to draw this graph, there is no way the second root is also negative, because this is the vertex. If you are touching this, you are touching y-axis first, and then you will touch x-axis as long as c is negative. So obviously, the second point where you are touching x-axis is always positive. Whereas if c is positive, if c is positive means you will touch x-axis first. If you are connecting this vertex to the point C, you will touch x-axis first, the negative part of x-axis first, and then positive part of y-axis. Right? If C is positive, that means the root, the second root is also negative. So negative into negative, which is positive, which is also which is what this means. Alpha, beta, if both are negative, then C will be positive. Right. In this case, we have already decided that the vertex is in Q3, somewhere here, and then C is negative. What that means is the other root is positive. Okay. So now we have derived this. Okay. So the graph is somewhere like this, and it is like this. This is the vertex. This is the vertex, and this is one root, and this is another root. Vertex is minus b by 2a. We know from the vertex both roots are equidistant. Right. So for example, if we take for ax square plus bx plus c minus b plus or minus under root b square minus 4ac by 2a. Right. These are the two solutions. What does that mean? Minus b by 2a plus under root b square minus 4ac by 2a, or minus b by 2a. This is minus b by 2a plus under root b square minus 4ac by 2a is this point, and minus of the same value. This is minus b by 2a, that is this point, plus of this value is this point, minus of this value is this point. Okay, so obviously this minus b by 2a is at the midpoint of both the roots. Right, now so far so good. This minus b by 2a. This is to the left of x-axis. Right. So for example, this point, let's say if we take somewhere like minus 2. Okay. And what we are doing, we are adding something and subtracting the same thing. For example, minus 2 by 2 plus 3 and minus 2 minus 3. This becomes plus 1. This becomes minus 5. Okay. If this is some point like this, then plus the same thing, minus the same thing. These are the two roots. Now, if you see the absolute value of these two numbers, absolute value of these numbers, this number is always, this absolute value of this number is always greater than this number. Why? Because this midpoint, whatever they are saying, this vertex is to the left of origin on the x-axis. Now, obviously, if we are adding something, the absolute value of this would be lesser than if we are subtracting the same thing from this. Right? For example, if this is minus 2, this point will become minus 5. Whereas plus 3, minus 2 plus 3 or minus 2 minus 3, this will become minus 5 and this will become plus 1 only. Okay. Only when this vertex is on y-axis, then absolute value of this and this will be equal. Okay. When you move towards left, obviously absolute value of this will be greater than absolute value of this. Similarly, if you are moving this vertex to the right, absolute value of this will be greater than absolute value of the left one. Absolute value of right one will be greater than absolute value of left one if you are moving vertex to the right side from y-axis. Right. So now essentially what we are saying alpha is less than 0. That is fine. One root will always will one root will be this will be negative. Why? Because the vertex is negative. Vertex is negative means one root will definitely be to the left of vertex. So one root is definitely negative. Okay, one root is negative. Alpha is less than 0. And then what we have realized, product of the roots is less than 0. That means beta should be greater than 0. Okay, second root is greater than 0. At the same time, the absolute value of negative root is greater than the absolute value of positive root. That also we realize. So the final answer is this. It's a beautiful problem. Just understanding the concepts of location of roots and relation of roots and the coefficients. That is very important. Right, guys? Hope you like this. The important point is how to identify the vertex and then product of the roots and then the graphical significance of product of roots. How we can, given coefficients, how we can estimate how the graph looks like. If the coefficient of x square is positive, obviously it will face upwards. And if there are two roots, that means it will touch the x-axis. And if the vertex is given by minus b by 2a. If the vertex is negative, then it will be towards left side of y-axis. If vertex is positive, it will be towards right side of y-axis. Right, guys? Thank you.